In this section, we are talking about tangent, and when we use the word tangent, that means that straight line just touch the circle. This is called tangent. So basically tangent is talking about this situation. While this is not tangent. Now we want to know by using the fact that only one point of intersection, delta is equal to 0. We want to find out what is the equation of this tangent is our target. For any straight line, we can let the tangent be y equal to mx plus c, while m representing the slope and c representing the y-intercept. That's what we learned in the last section. So the strategy is like this. Let the tangent like this, substitute inside to form our quadratic equation. Then we use the fact, the nature that only touch one point. Once we know delta equal to 0, then we can solve one of the parameter. So first, let the tangent be y equal to mx plus c. But in this question, they tell us that the slope of each tangent is 1. That means m here is known value, it is 1. Since slope equal to 1, therefore it is y equal to 1x plus c. It is greatly simplified. Now we focus on the point of intersection. That means solving the simultaneous equation. Y already the subject, that's one of the good things for slope-intercept form. Now we are going to substitute it into the circle equation. Therefore, we have x squared plus something squared minus 4x minus 10 something, and then plus 27 equal to 0, which is x plus c. Expand it accurately. That means we have 2x squared and we have 2c minus 14 times of x. And then we have the constant, which is c squared minus 10c plus 27 equal to 0. We already separate x squared term, x term, and constant term. Now we can use the fact that because it is a tangent, only one point, that means delta equal to 0. Since it's tangent, therefore only one point. Therefore, delta of the previous quadratic equation is equal to 0, only one repeated root. Then we can draw the conclusion. B squared minus 4ac is equal to 0. Now, B is 2c minus 14. A is 2. While c is c squared minus 10c plus 27. You observe this equation, even though it's quite long, but only c is the only unknown. That's why we can solve this quadratic equation of c. You may expand everything, or I would like to simplify it. I would like to extract 2 here. So inside the middle bracket, and then we extract 2. It will become 2 square, c minus 7 bracket square. After that, right hand side, we have 4 times, and then 2c square minus 20c plus 54 equal to 0. I keep 4 here is because I predicted that there will be 4. That's why I can divide both sides by 4 to keep the number smaller, easier to handle. So it gives us c squared minus 14c plus 49. Everything times negative 1. So we have negative 2c squared. Negative times negative, we have positive 20c and negative 54. Negative c squared, positive 6c, minus 5 equal to 0. You may use your calculator to solve this quadratic equation, or you may solve it by using factorization. Since something times something equal to 0, that means the first factor equal to 0 or another factor equal to 0. Both fulfill the requirement. So the constant is 5 or the constant may equal to 1. That means that the equation, there are two different tangents. The first one, y equal to x plus 5. Before that we just know x plus c, but now we know x plus 5. And the second one is y equal to x plus 1. It's normal that for a circle tangent we have two different y-intercept for a tangent. It's because if you talk about the slope is equal to 1, this is the first tangent. However, we have another tangent which is parallel at the bottom. Because this one is lower, so L2 here is y equal to x plus 1. L1 is y equal to x plus 5. One thing to remind you is you can't get the point of intersection position before you have the full picture of the tangent. So we can't solve this quadratic equation. We can only focus on how many real roots to solve the value of c here. Once we get the tangent, it's possible for us to find out the point of intersection here. But it's not asked in this question.